Welcome back. In the last lecture, we have mainly discussed about formatting, not formatting actually, how to take the input and how to take and get the formatted string, right? That we can pass multiple format specifier and various combinations we have tried. We have seen sometimes there will be an issue when you combine in the input integer and character. I have not demonstrated anything regarding the float because there is nothing special. Same issue we may face while we combine floating with the integer character that we have demonstrated with the integer and character, right? So you can try with the format specifier for the floating point. We can use percentage %f for the floating point, right? Then we can use percentage %lf for the double, and we can use percentage %l uppercase lf for the long double. Okay, so these are the three format specifier we used for the floating point type. One of the things that I have not discussed because our last lecture is already run over 48 minutes, so it's a bit lengthy, but you need to understand everything in detail, theory and syntax and all the thing. One thing I have not discussed that scanf also returns something. So let us now test here what scanf will return, and then we'll completely jump into the output part, how we can format our printf. We already know the simple printf string may have then with format specifier and the number of arguments. We also have many other things in the printf, right? So let us just check with the scanf statement and see what it actually returns. So quickly, let us just take one input here. I'm just taking one input using scanf so that we can see what it returns. Just to print the value of k. Okay, let's just run this. Waiting for the input. So I've given 34 as input. You can see it returns me 1. So what it is 1 may not clear, right? So let us add another variable. So it will be clear now. G, suppose I am taking another variable and also as integer, and I'm going to give input as a space separated. So I need to pass the address of G as well. Okay, now run. So it is waiting for the input again, and I give two space separated value. So actually the scanf returns, okay, returns number of input given. Okay, so previous expression we have used only a, so it returns 1. Now we have combined a and g together with two format specifier %d, so you can see the output, it returns 2. So in short, you can easily remember scanf returns number of input given. Okay, so in some point of time, if you want to check, right, how many inputs, how many input is actually given by the user. So, and if you suppose if you want 3 input, maximum 3 input if you want, okay, and but and you pass any three format specifier, integer, any combination, and while entering the value, user suppose enter more than 3. Okay, so you can cross check how many values that user actually entered, is it actually satisfy your criteria or not. Okay, that is the point that we have not discussed in the last lecture. Okay, so now this particular lecture we are totally going to be focus on printf, how we can format, right, a printf output, how we can format this. So before that, we need to understand the actual syntax of the printf, how it is actually works. So just to have a note of the syntax here. So this is the function, right, normally we use for the printf. We normally pass a format specifier and some argument, some argument over there. Let me go back to the OneNote here. Let us discuss here, okay, to understand the printf concept. Okay, so what is the syntax normally we normally write for the printf, and we are using a format specifier, so we called it formatted string. Why string? Because we pass it on the double quote, and number of argument depend on the number of format specifier we have used. So a standard printf we are writing in this way. Suppose I am using two format specifier here, and I need to pass two further arguments, so which satisfying those format specifiers, right? So if I just do this, so it will go here and it will go here. These things we already know, but if you just want to, if you look at carefully our output screen, okay, so let us just print on printf so that you can see. Even here our previous output you can check. uh, the outputs are now that is by default aligned to left to the screen, left to the screen. So if I assume this is my output window, so my outputs are always aligned towards left. So we have a certain mechanism, we can edit the printf function, and as per our requirement we can align the uh, output to the right alignment. Okay, any number of alignment that we can do. So for that we need to understand the printf syntax here. So let us just take the printf function. What are the other things we can include? We need to start with the percentage symbol, so because it will actually inform the console or printf that start of formatting is there. First thing, we can pass a flag variable, we can pass, or a value we can pass. We'll see one flag we can pass, followed by we can also decide the length of the output window, so we called it width. Okay, and third one we can pass specifically related with the floating point variable. So after a decimal point we can given the size of the precision up to how many decimal point we want to print. And fourth one we already used couple of time, but we don't know the actual of this, so we'll discuss going to that. Another one is length, last one is length. And after all this, normally we put the specifier, okay. So this is actually the correct format, that string of the printf, and here we can pass any value based on the given format specifier, right? So now let us just explore this syntax. Okay, so let us just start with the width. What is this width? Okay, so it is part of the format specifier. Okay, it is actually the part of format uh, specifier, all the format specifier. Okay, and normally as in width, what we normally pass as in width, an integer value. Integer value we pass normally between a percentage symbol and the specifier. So here you can pass an integer value. So normally width will represent as a positive integer value. Okay, so by which we can see our by using of this, what will happen, using of this our output will be right justified or right aligned instead of left aligned, which is the default behavior of the printf. So remember, the default behavior is printf is left aligned output. So here we can change it to the right aligned. So let us see the first one. Okay, so let us just take one printf. You can see, just if I use %d, and if I pass one value 67, and if I just execute this, you can see the output is already left aligned here. Okay, but if I just introduce one width here, one width, so the w between these two, okay, so we can just have a value 10, a positive integer value. Okay, what it means now, what it means, so let us just execute and see the behavior. Fine, I hope you understand. So let us just print the same value, right, without using any width. Okay, and uh, let us just use some more number, 54, and printf, and if I pass some small number, and pass the actual value again. So now let us see how it handle all those things. Here I have used 3printf for the same value. Okay, and here we did not pass any width. Here I pass width value as 10, and here I pass the width value is 3, right? So let us write this thing and understand the process. This one here, our width is equal to 0. Here the value of width is 10, and here the value of width is equal to 3. Now another part here, the output, the length of the output is what? 4 numbers. We can say 4 characters also, because when you print it in the output screen, it will be in character form. So what is the length? So length here, let us just write length of output. So length of output is 4. Here is also 4, here is also 4, here is also 4. So here we did not give any width. Okay, no width. So it is going with the default behavior of printf. Default behavior. Let us just execute and see. Okay, so here you can just check. I have printed 6754, and let me just add one \n so that they shifted into new line, and now execute. Now you can see there are 3 output. Okay, look at here. The first one is default behavior, that is left aligned when no width has been given along with the format specifier. Then in width, in the second case, we have given width as 10. So what it means? It means we are deciding the length of the output window. So we have decided it should be 10 characters, maximum length we have decided. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this up to this. Okay, fine. So what will happen in this case? It is going to compare the value of w with the length of the output. Okay, so length of the output is 4, which is actually less than w. So what will happen in this case? It will be, output will be right justified or right aligned. So you can see the output is right aligned. Okay, it shifted towards right. So how many it will be shifted? So what is the value we are printing? 6754, right? Just here, 6754 will be here. So at front, how many spaces? 1, 2, 3, 4, 5, 6. So it prints here 6 spaces to adjust with respect to the value of width, and number of characters present into the value that we're going to print, it is 4. So 6 plus 4, it is 10. So it will be right aligned. Fine. But in the third case, you saw here the width value that you have given, that is 3. So now here 4 is greater than w. So in that case, it will ignore the width value and default behavior will be applicable. Default behavior. So here you can see for the third output there is no alignment towards right of the screen. Okay, it is remain as left aligned. So these are the three things you can just note down and remember if you want to do some formatting while you do the producing the output in C programming through printf, right? So is it clear? Okay, so remember the width, as I mentioned here, our width is always what it is, a positive integer value. We'll see with one negative example what will be happen over here. So we are stick with the positive value right now, and it is part of the format specifier. Okay, so now we have used this and format specifier, right? And by default nature is left aligned, and we need to consider the width either as 0 and either width is greater than the value, or width is less than the value length. Okay, not value only, value length or length of the value, fine, whatever, right? So we can just understand this. In case of when width is less than the length of the value in our example, okay, so it will be same behavior like first one. Okay, right aligned, sorry, left aligned, not the right aligned, left aligned. This is the default behavior. So now let us introduce a few more things. Let us introduce now precision, okay, or let us just add see the flag one. Okay, see the flag one. Now can we just change the default one as a space? If I just go back, you can see the default output comes with a space. Can we just change this? Okay, let us try to change this. So we can introduce one flag over here. So this is our width, right? So if I just use 0, see what is happening. Output is padded with 0 instead of space. So how many zeros you can count here? 1, 2, 3, 4, 5, 6, as we have calculated earlier. So now what is this 0? This 0 is a flag variable, or flag you can say, flag variable. Okay, so default is space, okay, so we are modifying that space to 0 by how? By introducing a flag. Simple thing, you can easily remember. So now let's write here something. So flag always also comes with width, so we can use flag as 0. Okay, so can we use any other thing in the flag? So let us just try and see. So now I'm modifying that 0 to hash, and now if I just execute, it is saying that what flag used with %d hash, so it is not allowed. There is a warning. We cannot use hash because hash is reserved for some other purpose. Okay, so let us just take @ no. Okay, see again the issue, it cannot handle this. Okay, so can I use asterisk? No, it cannot use because it has a separate meaning. We cannot handle this. Fine, so only 0 padding is possible. Along with, if you did not use 0 padding, it will be the space. So I hope now flag is also clear what we can do with the printf. I'm using here integer. Let me just show you. Along with the string is also possible. Okay, so we have not discussed the string yet, but we can just print it. I'm not going to declare or take input anything over there. So I am taking the value of width is again 10. Okay, and we're going to print a string. So print a string, we need to use format specifier percentage s. So s is the specifier, percentage represents formatting, and 10 is the length of the width. And now here I am just printing one simple word hello, and let me just show you the output and see. Okay, so it takes some time for the server. Now see here again similar behavior. Similar behavior, that hello that printed is also get the right alignment. Okay, fine. So with the string also it is works. It's become the right alignment. Fine. Okay, so now what remains here, let us just look at the precision. Okay, then you will see the length. So in precision, how, let me just take one example and how it is works. So to just remove this integer precision, normally we use with the floating point, right? All three. Okay, all three floating point types. So printf percentage f is one of the format we are using, right? uh, Now suppose here I pass a value 89.76, okay, 54, and the value also 78. So look at the length 1 2 3 4, 1 2 3 4, 8 values with decimal point, total 9 characters is going to be displayed into the screen. Okay, so let's just check this. I did not use any precision, so as it is value we have printed. So let us note down the syntax of the precision, how to use. So the syntax of the precision, you just note down how we can do. It is normally comes with an width. It is always comes in this fashion. Printf percentage, okay, width, then precision. That's why I told width is a part of the format specifier, right? I have mentioned here. So precision, and next we need a specifier. Okay, so and the value. So it is reserved for floating point types, right? So how it will be work, note down the syntax. So let me just write it here. So I'm adding the width value here. So width is, I've decided 6, and after decimal point I want up to 2. Okay, so here this 6 is width and 2 is precision, means up to second decimal place. So what is the total size of the output window? So total size is, okay, total size of the output window is 6, including the decimal point. Including the decimal point, remember this. Okay, so but what is the value that we want to print? So we want to print a value 8978.7654. So what is the total length of the value? 1 2 3 4 5 6 7 8 9. So now let's see how width and precision behaves, because we have seen during the integer, when our width is less than the length of the value, it simply ignores and it adopted the default behavior, right? That is the left aligned. So how it is going handle in the floating point, let us see. Now look at here for the width and precision, it doesn't print the complete value. Look at, we have decided the total length, okay, total length as 6, okay. So and now if I just reduce the length here, okay, 8.7654, and just if I execute, now you'll understand what is happening. See, in this case, our uh, width is equal to 6, okay, which is greater than the value we have 8 point. After the decimal place we want 2, so our after decimal place we want only 2 values, so it will be definitely scale up based on the value. So second number here is 6 more than 5, so it will also get 8.77. so the length of the W is greater than the number of character present in the output. So number of character is 4. So how many spaces is going to be padded? It's going to padded 2 more spaces. You can see here 2 more spaces. Okay, so now let's go back to our previous case. When we use the large value, what will happen? So I've used the very large value, okay. So now here you can see our W is equal to 6, which is less than the value that we're going to print. After decimal point, it is fixed only two places, right? After decimal, there is no problem, only we'll have 0.77. But before that, there is so out of 6, what is the relation, how the division has been done. 1 point is reserved for the decimal point. Then before the decimal is we have 3 is reserved, so 3 plus 1 is 4, and after the decimal we have 2 is the reserved. So now 3 plus 1 is 4, 4 plus 2 is 6, right? So this is the case here. But here now look at the numbers present before the decimal point. How many? 1 2 3 4 5 6 7 8. So there we already have 8, so now 3 less than 8, so what will be the outcome? Ignore. Run it. See, it's ignore. Ignore where? Ignore in the width part. It did not ignore the precision. It ignores the width part. Even though suppose if I pass a equal value, let me just show you here. How many? 3 now. So yes, now see, I have used exactly 3 in that before decimal point. Including decimal point we have 4, and up to 2 is the decimal place. So 4 plus 2 is 6. Now run. Now see, it is again ignore. Okay, so anyway, what is the conclusion here? The conclusion here is that we will not compromise in this side. Will not do any compromise. We will not going to lose any value for the formatting purpose. If the number of values before the decimal point is satisfying the length of the width, so it will be going to the right alignment. If not, default nature will be applicable, the left alignment. Okay, so I hope that part is also clear. Comment on the video if you need more explanation. Okay, I'm discussing it very slowly. We are just building the basics. Okay, so now our flag is also over, width is also over, precision is also over. Let us just do one more extra thing here. We always come up with a fixed size width, that is 6. Previously we tried with 10 in the integer. So it is a static value, we cannot modify, right? So but C also tells us that we can have dynamic width value. It is also possible as a dynamic width. Means it is not mandatory that we should always go with a fixed value here. We can have dynamic width. So for that, please see the next example. Syntax is different. we can have a width. So width, I told it is always positive integer, so let us just write width. Okay, and let us just take input about the width. Okay, so if you want unsigned, you can also fix it because it is always positive one. As is it unsigned, the spelling is okay now. Yes, unsigned integer. uh, and instead of percentage d, so normally we use percentage u for the unsigned, and here we can pass the address of width. So whatever the value you take from the user, it also can act as an width. So in this case, instead of the value of the width, here we need to pass an asterisk. Okay, and the first parameter is width. So let us now just try this and see some issue. Oh, spelling mistake, just one minute. Width. Okay, it is waiting for the input. So now I give width as a 20. Now see, it is automatically adjusted. So no need you should go with as a pre-planned as a fixed width. Based on the user input, you can also modify. If I just use 2, which is less than the value present in this side before the decimal place. So let's see now. See, it is the default behavior is repeated. You can, I'm using here this asterisk that is called dynamic width based on the user input we are dealing. And remember, in this case, the first parameter should be width. You do not use first parameter as the value. First parameter will be replaced this the asterisk with its value. Okay, it is, we can do with the integer also. We have not demonstrated anything with the character, so no confusion. Let us just do just one example with the character as well. Printf percentage c, and here I just use asterisk. Okay, and I going to pass the width and a character, suppose s. We're going to print, it should be new line. Okay, now run. So I've given the width 10. See, it works for all, no restrictions on the format specifier. Okay, so that thing you can do. Now what if we pass a negative width? Another scenario. So every time we are passing a positive width, as even though in the during the discussion also I have mentioned it is an integer value. Okay, positive integer value. What will happen if we pass a negative width? Okay, so just check it here. What will happen if we just pass a negative width? So I am just removing the unsigned from here, and for unsigned it becomes signed now. So we can use percentage I and run, and now if I pass -5, so see what happened. For the negative value, no negative width, it doesn't uh, uh, aligned in the right. It considered the default behavior. It aligned the output towards the left of the screen. Okay, and suppose if I want to use a flag variable, let us just see if I just want to use a flag variable here. Not possible. I just let us used with the integer and c, \n percentage d, and here I going to fix the dynamic width, and before width we need to use the flag variable, right? And here we are just passing the width and the value is 45. So now let us try. Okay, waiting for the width. So suppose I would given width 10. Now see what happened here. Oh, I given a positive width, it should be negative width. So let us enter a negative width -10, Now see, when we enter the negative value, and even though we have used a flag with the integer, it doesn't make any impact. All the outputs are left aligned. All the outputs are left aligned. Okay, as a default nature. But is it actually the default nature or something else? So let us just check what is happening here. So let me just reduce all those printf so that you can understand. Let us just come up with only one printf. Okay, now, and let me just save the return type here. Okay, like scanf, printf also returns something. Okay, and now that print the value of k, what it is actually print here. We'll just move to the next line. Okay, run. So now if I just enter a negative 8, okay, we get the 45, but why k is 9? Because k is actually what? K is actually the return value of printf. So what printf is returned? Printf returns the number of character it prints. Okay, number of character it prints. So here we already print only two character. 45 have two character, 4 and 5. But why it prints 9? It prints 9 because after 45 it prints the remaining spaces. Okay, it prints remaining spaces. So total it prints 9 characters. 5 is the value and remaining 7 are the spaces. So what it means? It means that when we use a negative, or yes, negative width, when we pass negative width in the printf, uh, it aligned left, no problem, but output plus spaces will be printed. So spaces will print after the value. So here we cannot use 0. I have used the flag 0 here. Still it not works. Okay. So here that's why I consider the return value of printf, and this is the way it is works. Okay, so here we have also discussed the precision with positive, negative both, and flags. One thing is remain, that is the length. What is length? We have already used this. Okay, let me just discuss one more time. This length comes with format specifier, right? We have already used percentage h. Okay, and we have used percentage hu for the unsigned short, right? We can use percentage l for the ld for the long integer, right? We have also seen we can use percentage ll for the long integer. These are called length. Okay, for the large values we can use them. We can also use percentage l with f for the double, and percentage l with uppercase L with f, this is for long double. This is for double. This is long integer. This is short integer, unsigned short integer, and it is for long integer. Okay, so these are the length parameter. We have length flags, or not flags, they are called the modifiers. Okay, length modifiers we have already used, but apart from that, C programming also supports couple of them. We have another length modifier, that is Z, which represents a data type size underscore t. I hope you remember when we use the size of operator and we pass any type inside this and it returns the size of that data type that it requires. Okay, so this it returns actually type size underscore t. So size underscore t is similar to unsigned integer, you can say, or unsigned long integer. Okay, so instead of if you remember during the size of we have written percentage hu. Okay, so let us just check it again. Okay, printf, we are using percentage unsigned shortener, so hu, and if we use size of, and if we pass int here, okay, it's long unsigned, so yes, lu is the format specifier actually. But she says that the size of returns a type of size underscore t. So we have a specific modifier here. Instead of percentage lu, we can use z along with the d. We also get the output without any warning. Okay, so let me just show you another one. So I can declare a variable size underscore t, size is equal to 789, and let's try to print this value because 7894 is an integer, right? So let us just try with percentage d. Let's see is there any warning or not. Okay, and just yes, run this. See, we get a warning. It is what it is saying. Format percentage d expect argument of type int, but argument 2 has type size underscore t, right? So for size underscore t, what we need to do, we can use z here and d, and if I just run it, now see we get the correct output for the size underscore t. Okay, uh, this is one of the example that we can do. Another one is also there, another type is there in C programming. We can use even j, so for that we can use a maximum value int max underscore t is one of the type, and if we just take a highest value of integer, okay, fine, and printf percentage jd, and we are passing max and backslash n. Okay, beyond the value, huh? What is the warning we are getting here? Overflow of the conversion. Okay, so can we use jld? Is it the long integer? I don't think so both of them work together. No, not possible. So let us just use percentage jd and 20 bits digits, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, now try. Still we are getting issue. Overflow, value is overflow, long integer. So can I just make it this way? Is it works? No, it's overflow. Value is overflowing. Just reduce the value. So why it is? I'm using very small value now. Still it is saying express argument of type, but argument 2 has of int type. No, it is saying that argument of type int max underscore t. Yes, we have given argument type of uh, int max. We have assigned it int max underscore t, and we have pass here percentage jd. So if I just use, I'm not sure it will not work with the j alone. Okay, so jd is the right format. Let us just check this. Huh? Just let us just check. Maybe I forget, but this is the way we should do. Okay, print one int max type using printf in C programming. Last example, I think it is over. After that, okay, we need to include one header file. Let's just take this example, but I'm using J here. When to use percentage JD to print a value in C programming. See, similar thing we have tried here. The very large value, I think for that we need that header file. So let us just try with this. The header file, I think if I just included this, so I've included the header file now. And if I just increase the value, I continue with the JD here. Yes, now it is works. Okay, so that is the mistake I have done. I forgot to use the header file int types.h. So for the large number, we can use another length type here, that is percentage j. Last one is remain. Normally we use to calculate the difference between two pointers. So pointer is a separate concept. We'll see that one later. Actually, another type we can say td we can use with the find the difference between two pointer. So till that pointer topic we are not coming. That is difficult to understand because we need to first discuss what is pointer and how to declare it. Separate concept, right? So as of now it is okay. We have covered in depth about the printf complete thing. It is already around 48 minutes. Better to stop. Just a quick recap for within a minute what we have covered. We have done this basic formatting with the printf. We have seen how to use width. Okay. Then we have already seen, yes, how to use flags. Then we have seen how to use precision with the floating point number, width dot precision, the length with the short integer and others, along with the specifier, and how to control the output and how to format the output window. By default is the left aligned. Okay, so please give a thumbs up, like the video. If you enjoy the content, please do the subscribe. Thank you very much.